Good morning, class, or good afternoon, class. Today's aim is how do we use sampling to calculate total population? For those who have joined online, make sure you have Google Classroom open, make sure you have the slides open, make sure you have the handout. The first thing I need you to do on your Cornell notes, solve the first two do not questions. You have exactly 5 minutes. You can work with a partner, but I prefer you doing this independently. While you're doing this problem, I will circulate and check that you did your homework from last night. Please get started now. Let me see your homework. Good. Homework. Okay, great. Thank you. Online students, please submit your homework on Google Classroom so that I can view it. Thank you. Okay. We have 4 more minutes. If you're finished early, just cue me so I can come and check your work. There's 2/3. So we know that Johnny wants to know that Johnny knows that 2/3 of the class is going on a field trip, right?
Mm-hmm.
So is there more students or less students?
More.
In total in the classroom, right? That's very good. Now we know all, like imagine your normal class, like 30 students, right?
Mm-hmm.
If 24 students went to a trip, we're missing the whole amount, right?
Mm-hmm.
What does that brings back? We're talking about whole and parts. Very good. Fractions. Okay. So we know we have 2/3, right? And is 24 a whole or a part
Part.
of a whole, right? So it's gonna be an equation just like above. So use that context clue to try. You have 2 minutes. Keep going. Cool. Mamun, how are you doing? Okay. We will. Okay, that's good. Keep going. We have 1 minute and 30 seconds. Please make sure you're ready to share. Person said if I were. pencils down, pens down. So, let's quickly go through the two solutions. I saw that most people were able to do number one fairly quickly. Number two, most students struggle. So, we're going to review. So, the first questions we have, and I'm going to do it here, is it says solve 11 over 15 is equal to x over 75. And we are solving for what?
X.
Okay, great. So Tanya, can you come up here and quickly show us how you got what you got? Thank you. Everybody else, if you make sure to check your work that you did this, if she did the right steps, if you made any mistakes or if she made any mistakes. Explain while you're doing it. What are you doing?
So I'm gonna do cross multiply and multiply 75 by 11, and then I'm gonna divide that by 15.
Okay, so she's, what is that called? Isolating?
Variable.
Very good. Isolating the variable so that we get x by itself. So 75 times 11, Tana, can you help her?
825.
Very good. You can all be a calculator. And divided by 15 gives us what?
55. So x is equal to 55.
Great, thank you. Thank you. Have a seat. All right, did everybody get 55?
Yes.
Great, thank you. Online as well, very good. We all got 55. Number one was fairly easy because we already have an equation and they tell us exactly what steps, what we need to do. We need to get x by itself, so isolating variables. Now, number two, although similar problem can be a little tricky because we're looking at a word problem and the information can be a little jumbled. So let's break this down since we saw that most of us had some difficulty. All right, what do we know? The scaffold.
That there's 2/3 of the class is going on a trip.
Okay, we know. We know 2/3 is going on trip. Okay, what else? What does that mean? If 2/3 is going on trip, what's left? 1/3. So 1/3 is left. Who didn't go to the trip? Right? What else do we know?
That 24 students went on it.
We know 24 students on trip. So what are they saying? They're saying that of some random sized class, 2/3 of that class went on a trip. So we know that we have some fraction, 2/3. Of that 2/3, the 2 here will represent part. Make sure you're writing this down in your Cornell notes. And what does the 3 represent?
The whole.
Very good. The whole is equal to, now 24 students. Are they part or whole?
Part.
Part. Very good. So is that going to go on the numerator or denominator?
Numerator.
Very good. So 4 over, what is the denominator?
X.
Okay, so we'll say x. And when you're solving any math problems, you say let x equal the total number of students. Okay? We always have to define our variable. We can't just make up variables. Now, did you get that?
Yes.
Great. All right, let's continue. So, Mountain, can you guide us? What's the next step since you were able to do much more? What's the next step you took?
For number 2.
Yep.
When solving this problem, I had 2 over 3
Mm-hmm.
equal 24 over x.
Keep going.
After doing that, I had cross multiplied.
So what did you get?
What happened?
What did you get?
The answer?
No. Keep going. Tell me the next step.
So I cross multiplied
Okay.
each of them like 2x and 3 times 24.
So he cross multiplied. So 2 times x is 2x. 3 times 24 is?
3 times 24 is 72.
Okay. What's the next step?
Now 72 divided by 2,
Very good.
which will give you 36 as x equals 36.
So, x equal 36. So, therefore, what can we conclude? Tamina, what can we conclude from this value?
That we had to divide
No. What does the solution tell us?
how many students are in the class.
Very good. How many students are in the class? So, this class size is total of 36 and only 2/3 of them went. Right? Very good. So 36 students in that class. Okay? So, let's get started with our lesson for the day. Today, what we will be doing is using fractions and proportion to calculate or understand population and how do we define what is, endangered animal or what is the population of certain species. You can't physically go tag every animals, right? So this next slide. Can somebody read that nice and loud, please? Tanya?
Scientists often study the health of a habitat by gathering data about the numbers of animals that live in the area. Suppose you wanted to know how many robins lived in a particular forest.
So let's think about that for 1 second. Why don't you turn and talk with your partner on what are just brainstorm some ideas of how do you think scientists are actually doing that. So turn and talk for 30 seconds with your partner. What are some ways scientists might be doing those?
What do you think? They probably gather little by little and see, they gather little by little and count and probably mark them and see how much in one group and then they do it one by one.
Okay, great. All right, let's bring it back. 3, 2, 1. Mamun, can you share us one idea that you think scientists use to calculate the number of, let's say, robins here in a particular forest?
I mean, we can try to, we don't really know the numbers of habitats, the data that we don't know the number of animals.
Mm-hmm.
We use equation as before doing now.
Okay, so we can set up some sort of function, some sort of equation.
Function.
Tamana, what did you say earlier?
I said they probably gather specific groups and tag them or mark them,
Mm-hmm.
and then they do the same
Okay,
one by one.
so that's very close to what we're going to do today. So, questions. How could you count the number of robins? These are some big questions that we need to answer while doing this. If you try to gather them all, would you be able to know if you had them all, right? So if you go to, let's say, Central Park, and you see a couple of robins, is that all the robin that exists within Central Park?
No.
You don't know, right? Because some might be in a different part of the park. Some might be, flew away for a few days. Whatever the case is. So we wouldn't know exactly. And what could be the easiest yet most effective way of counting? So we have to come up with some sort of calculation, some way to recognize what the population of certain animal species are. So, little background. This is a familiar problem for ecologists, and it's solved using a method called Capture-Recapture, devised by Danish marine biologist Carl Peterson in 1896. So he was a marine biologist who wanted to kind of understand what are the tools we need in order to learn about population and if certain animals are in danger or not, and how do we actually know, and how do we inform people after, right? So he devised this method, and we're going to use this method today to calculate the number of robin in, let's say, Central Park. So what you will need, per your exit ticket yesterday, we spoke about being prepared at home and in class. So you will need beans, markers, cups, and the handout that is posted on Google Classroom. So you should all have the following, okay? A handful of beans. I only put up to, let's say, 1/8 of the cup, or a little bit more, 2/8 of the cup, and 1 empty cup. So the method here is to take the sample of the population, mark each item, put each item back into the population and ensure they are thoroughly mixed. Take the second sample, count how many of your sample are marked. The proportion marked item in your new sample should be the same as the proportion marked in the items in your first sample. So all that means is as follows. So Mamun, I will show you. I'm going to fix the computer so that you can see what I'm doing. And Tanya Tamana, you can see here in class while I do this, all right? So Mamun, can you see my screen?
Yes.
Yes. Okay. So everybody take out your handout. Everybody should have the handout that's either on your computer or on paper. I'm going to use the paper one here. And we will get started. So let's start. So it says, number 1, from the cup, capture a handful of beans and count the numbers beans that you captured. So what I'm going to do, can you see what I'm doing? So I'm going to just capture a handful randomly, right? And I'm going to mark each of these with a marker. So, and you should do it both sides and use a dark marker so that it stays permanent. So let's use this. So we're going to say 1, 2, and you might want to double check sometime when you're recapturing that both side is marked so it's easier for you to count. Your hand might get a little messy, but that's all right. So everybody should be doing this right now. Just capture a handful. If you're working with a partner, one partner can do it and the other partner can count. Okay? Okay, here I have the markers. I'm going to count to make sure I have the right numbers. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 33. So I have 33. And I'm just gonna note it somewhere here. Just for it, I marked 33 beans. Okay? So I marked total of 33 beans. And then it says, put the beans back in the cup and shake it up very well. So here's the next part. Eyes up here. I'm going to take my beans, all the captured robins that I found today. I'm gonna put it back in it. And I'm gonna use this to really shake it up. Give it a nice shake. Do you think it's well mixed?
Yes.
Good. So, we did step 1, step 2. It says, from the recapture a new handful of beans. So, now I'm going to again put my hands in the bean and capture a couple of new ones. And couple a handful, so I have a good number. And then it says, how many total beans are in your handful? Okay, it's just 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. I have 30. So it says, how many total beans are in your new handful? I have 30 beans. Okay? How many beans, marked beans are in your new handful? So of those new 30, how many are marked? And this is when I said, make sure you check both sides because sometimes it might not be marked. So here, not marked, not marked, not marked, not, all you're going to do is separate the two beans, okay? So, look like I got a bad handful or a good handful. Whatever the case is, this is day 2, or I went to capture some birds. So I have about 3. So in my new handful, I only had 3 birds that I saw the second day. Does that make sense?
Mm-hmm.
Okay, so again, I'm going to take these beans, put it back in the cup, mix it up really well, and then before we get to the next sampling, let's read number 4. It says, write a ratio representing marked bean in the handful. So we had how many marked bean?
3.
3. Total bean in the handful?
30.
30. 3 over 30. We can reduce that, right? For now, let's leave it as it is. Now, what you're going to do for the next 20 minutes is complete number 5, but on the second page where it says number 13, please go to write 7, 8, 9, 10, 11, 12. I would like you to try 12 times. Now, again, let's go back to number 1. So I did my first one. Number of marked beans, I had 3. Total number of beans, I had 30. Ratio of marked to total, well, the ratio was 3 over 30. For now, leave the gray spots blank, but all you're going to do is try it, keep going, fill out up to 12. All right? Once we are done with the 12, I would like you to answer question 6 through 11 before you move on. All right? I'm going to give you exactly 20 minutes for this problem. Oops. 20 minutes for this problem. Please get started as soon as I say go. So I'm going to set the timer. Please make sure you're doing this. I'm going to walk around, make sure that you are on task. A little bit more than 20 seconds, but that's all right. Please get started. Again, the method is on the bottom of the page on the slide if you need help. I'll walk around and see if you need anything, all right? All right. Mamun, how you doing? Can you hear me? It's alright. Give me 1 second. Can you share your screen with me? I'm gonna stop sharing. Can you share your screen? Great, awesome. Let's see. So you got 24. And how many marked beans are in your new handful?
About 6.
Okay, about 6? You gotta write the exact number.
Yes.
Okay, so make sure you write this down. I want you to continue doing some trials and please have this done in 20 minutes. All right, continue. I'm gonna now share my screen so that you can see the slides, all right? And I'll leave this on the board so you have the timer. Ooh, shoot, the timer went bad. Oof. I'm gonna say 17 more minutes. All right, please continue. I'm gonna come around, check the date. Great, great, keep working. Make sure always check both sides because you might be missing.
So complete.
I think you will use the pump here, okay? How's it going, Norman? Thumbs up, thumb down. What's happening? Alright, keep going.
Six.
Once you get to trial number 10, please conclude.
Fifty-one.
Great. Let's continue. Alright, first move on to problem number 6 here. Again, once you have done 10 trials, I would like you to answer questions 6 through 10 with your partner. Please get started. Make sure you read the questions carefully and use what we did from the do now to answer those questions. If you need help, raise your hand and I'll come around.
First trial.
Mm-hmm.
Three, four,
Mm-hmm.
three, four, the mark you copy the cross.
Great. You can use a calculator to help you with the calculation.
Yes. 126.
Perfect.
The goal of the trial is to determine the total
What is the total number of
beans.
robins
Oh, sorry.
in the particular forest?
Mhm.
Total number of robins.
Okay. And
Alright, great. Keep going. Answer number 8, 9, and 10. Once you're done. Mamun, how you doing? What question are you up to? Very good. Keep going.
So basically just do the same thing as all of them. Okay. That's really tricky. So, if we type it something.
So, what do we get? 3 divided by 20 is percentage wise.
In percent?
Mm-hmm. Yeah. So, let's read number 8. What is that?
Label the gray column in the table of question 5.
Mm-hmm.
Using each of the trials, write a proportion and solve it to estimate the total of number beans in the cup. Each time you calculate, enter the value in the gray column of the table.
Okay, so all that means is to rewrite this in terms of a
Percentage.
percentage. So what is 3 over 20? It's a percentage. How do we get a fraction into a percent? Okay, then by
100.
100. Very good. So what's 3? Let's do it on a calculator. 3 divided by 20 times
Times 100. 15.
15.
15%.
Yeah, we can say percent. Or better yet, let's leave it at 0.515 for now. 0.1515. Alright, let's erase that. So write everything in terms of decimal and for all of them. So go quickly.
So the amount?
Yep.
Let me just this.
Okay. Give me 1 second. You can share your screen.
17.
I'm gonna stop sharing mine. Class, keep working while I check the remote. Great. Number what? Number 8? Okay, so go up. Let's go back up to the table. Okay, so basically what we want to do is get the estimated value of this ratio. So the estimated value here is just going to be 6 over 24. So what is 6 over 24 as a decimal? Okay, so write that down for each of them. So first one, you're going to say 6 divided by 24 gives you some decimal. You're writing that down. It should be a decimal. 6 divided by 24 is a decimal. Alright, keep going. Okay, good. Alright, I'm going to unshare. Can you? Okay, I'll share my screen back. Alright, class, we're going to stop at this point and let's answer some vital questions. Alright, so let me get up here. Let's check how much time left. Okay, we have a few more minutes, so let's answer some vital questions. So, it says The idea is to do as many trials as possible. So, very important question. Number 6. What's the goal here again?
To find the total number of robins in a particular forest.
Very good. Using the data, what do you propose that the total number of robins in the park should be? For number 7, using the data from the first trial we did, what is the total number of robins that your group came up with? So what is your answer to number 7? What did you get?
126.6.
Okay, yeah, 126.6. Well, can that be a number of robin?
No.
So we have to round up or down?
Up.
Very good. So,
127.
Mamun,
Yeah.
what was your answer to number 7?
Number 7.
What do you think the total number of robins are in that forest?
For number 7, I had got 0.013, etc.
Double check your math. It should not be a fraction or a decimal. It should be a whole number.
Wait, let me check for a second.
Okay.
75.
Okay, 75. So he has a smaller batch. Great. And we don't need to round that. That's a whole number. So we're assuming, I'm gonna just borrow this. We're assuming that there is 127 beans in this cup. In order to really calculate, we need to take an estimate. And this is where the second part of the mathematics comes from. The gray that you labeled, all these gray spots or column where we said this is the estimated total, you took what? The decimal values of each proportion, right?
Yes.
If you're doing random sampling different times, you get 40, 50, 30, whatever. How do you find a good sample? Like, what do you think a good estimate would be? How do you find an average of certain numbers?
Like a percentage?
Okay. Let's go back to the word average. How do you take average of something? So if you're in a classroom, you took a test. First test you got a 90, second test you got a 60, third test you got a 40. How does your teacher calculate your test score average?
You add everything
Up.
in total,
Mhm.
and then you divide it by how many.
Very good. How many are there?
Yeah.
So what we're going to do is add all those decimals and calculate the exact number. Now, because we're running short on time, what we're going to do is you're going to have to extend this by completing question 9, 10, and 14, 15. So the remaining questions, and I want you to think about just how many sampling would you need to do? Like, can you go to Central Park 10 times, like one day after another day, 10 days straight, and say that's the end of it? Or you have to do multiple times, maybe different seasons. I want us to continue to think about this while we're doing that, and tomorrow we will continue the class, and your homework is posted again on Google Classroom. It will be found right here under homework. Your homework for today is to two things. Finish the handout either at home or with your partner after school. If you need more help, stay after school. And you have a few questions to answer. All right, class, that's the end. Thank you. Goodbye.